Hey guys, today we're going to be teaching you how to use multiple indicators to determine the pH of an unknown solution and then ultimately trying to get it into the smallest pH range. So we're going to give you an unknown acidic solution and an unknown basic solution, and you're going to have to determine the narrowest range of what the possible pH could do. And so the indicators we're going to be using today is bromocresol green, phenolphthalein, phenol red, bromothiol blue, and methyl red. All of these indicators will change colors in a specific pH range. And so we're going to drop these into multiple beakers, see what colors, and based on that, we're going to build a pH range. And remember, the goal is the smallest range possible. It's not really helpful to be like, well, it's anywhere between 0 and 14. We like to say like, oh, it's between 6 and 7, the pH. So the gist of this is, and this will make more sense on the next slide, is we're going to choose the highest pH on the low end and the lowest pH on the high end. That's what will allow you to have the smallest pH range. Okay, the first one we're going to do, and if you were in class, we would have had 1, 2, 3, 4, 5 beakers. 2, 3, 4, 5, all with a little bit of our unknown basic water. And remember, our goal is to figure out a pH or a range of pH for this basic water. And so we've already put in the results of the 5 indicators, and then we're going to use the chart above to build a pH range. So bromocresol green turns blue, so we're going to find bromocresol green, and it turned blue. Oh, I've lost my pen. So the only time bromocresol green turns blue is if your pH is between 5.4 and 14. Okay? Phenolphthalein turned light pink. So we'll find phenolphthalein, and when phenolphthalein turns light pink, the pH is between 8 and 9.8. So that was super helpful, even just looking at these two, is that we know a minimum is it had to be a pH of 8. Okay, let's look at our next indicator, phenol red, turned red. So let's look at the chart. When does it turn red? When the pH is between 8.2 and 14. Okay, we even got a little more narrow on that, knowing that the minimum has to be 8.2, otherwise phenol red couldn't turn red. Bromothiol blue turned blue. And so looking at this chart, it turns blue between 7.6 and 14. And then methyl red turned yellow. So when does methyl red turn yellow? When it's between 6.2 and 14. Okay, so we have our results, and now we have to build the range. So it says on the low end, pick the highest number. So our highest number is 8.2 because that's the minimum for phenol red to turn red. And then on the high end, pick our lowest number. And so our lowest number is 9.8 because otherwise it wouldn't have turned light pink, it would have turned a different color. So this is going to be our narrowest guess of pH. So our basic water has a pH between 8.2 and 9.8. Okay, so now we're going to do the same thing, but for the acidic water. So we're going to do the same process we just did above. Bromocresol green for this unknown acidic water. So we had 5 beakers if you would have been in class. When we dropped the bromocresol green, that beaker, the first beaker, turned green. And so bromocresol green only turns green when the pH is between 3.8 and 5.4. Phenolphthalein was colorless, so phenolphthaleine's colorless when it's between 0 and 8. It's a pretty broad range. Phenol red, it turned yellow in our unknown acidic water. So phenol red will only turn yellow when it's between 0 and 6.4. Bromothiol blue turned yellow. That's between 0 and 6. And methyl red turned red, which can only turn red between 0 and 4.4. Okay, so if you remember, we pick the highest number on the low end, which is 3.8. So that's our minimum. Otherwise, bromothiol green wouldn't have turned green, so it had to have a minimum pH of a 3.8. and then we pick the lowest pH on our high end. And so 5.4 looks pretty low. It's not going to be 8, not 6.4. 4.4 is even lower, because if you went outside of that, methyl red would have turned a different color. So our best guess to our unknown acidic water is that the pH ranges between 3.8 and 4.4. And so these are how you can use multiple indicators to help you find the unknown pH of a substance. Okay, the last thing is, if you are wanting to do a reaction and just use one indicator, what would be the best indicator? And so to make this choice, you would want to pick an indicator with the smallest pH range in a transition range, okay? Because we want to see that color change happening. And so if our end pH was 5.6, what indicator would be best? So bromocresol green, it stops at 5.4, so that wouldn't be good. That doesn't include 5.6. So it looks like our best indicator, if our reaction was wanting to end at a pH of 5.6, would be methyl red. All right, and that concludes the end of our indicator demo.